Hi, today I'll go over the concept of a diode. Now, what is a diode? A diode is one of the most important circuit elements in microelectronics. Here we see the circuit symbol for a diode that's shown in popular circuit diagrams. Now, a diode can be described as a non-linear circuit element. Now, what does this mean, non-linear? Because this characteristic is very crucial when it comes to the diode and how it functions. So it's important you know what we mean by nonlinear. Well, to understand what nonlinear means, we should look at a linear circuit element, like a resistor. A resistor, for those who don't know, is a circuit element that limits current and it's used as a load. Here is the circuit symbol for a resistor. Now, to see why a resistor is called a linear circuit element, we must look at the voltage-current relationship. Now, if you look at a resistor and you apply a certain voltage across the resistor, the current going through the resistor will be like this. As you can see, this is clearly linear, a straight line. This is why the resistor is a linear circuit element. Now you look at a diode. You look at the voltage across the diode and the current, and you'll get something like this. As you apply voltage across the diode, this is how it will affect the current. Now this is why the diode is nonlinear. Now, next I'll explain this graph and why it's so important to how a diode functions. Okay, now I'll further explain the voltage current characteristic of a diode that I showed previously. Now let's draw a graph, a bit bigger this time. We've got the voltage here and the current here. Now, as you've seen previously, the relationship basically goes like this. Now, what does this mean? How does this show how a diode works? Well, what this graph shows is as you have a diode, and it also goes to the negative regions a bit. Now, as you have a diode, once you apply a voltage to the diode, the current will always be zero. Always. And then, as you get to a certain point, past that voltage, the current will be infinity. And this point is called the activation point. The activation point is usually 0.7 volts for silicon diodes. 7 volts. So as you can see, before the activation point, apply as much voltage as you want, as long as it's lower than 0.7, and the current will always be zero. After the activation point, you can apply as much current as you want, but the voltage will stay at 0.7. Now, what's so great about this? This shows how diodes can control the flow of current, and this is what makes them so crucial in technology today. Now, let me show how this works. Here we have a diode, and the arrow basically indicates the direction, so it's going this way. Now, let's say we apply a current through the diode going that way. Since the current is going this way, that means the voltage across the diode will be negative. Since the voltage is negative, the current will be zero. So basically, current cannot flow this way. It just can't. Now, if I make current flow this way, now I can get the voltage to be above 0.7. Then I can put in as much current as I want going this way. See, this is how a diode can control the flow of current. Now I will show some application of the diode in modern technology. Now I will go over the main application of a diode. Why is it so important? Now, the main thing a diode does is it turns AC current into DC current. Now this is important because AC current is a current that's used to deliver power to our houses because it's more efficient over long distances. But DC is how we power most of our home appliances because you don't want the current in your devices turning on and off. Imagine a TV where it just keeps turning on and off. That's useless. So it's important to turn AC into DC. Now, the way the diode does this is basically the main concept that we talked about. It can only make current flow one way. So if you look at an AC voltage graph, it's something like this, oscillating. When you put it in a diode rectifier circuit, it basically looks like this. Turns AC into DC because it cuts off the negative parts, and then a capacitor can smooth the rest. This is the importance of a diode. Now, I hope you enjoyed this video, and thanks for watching.